Yes, we are continuing with hyperbola function. The first question says determine the equations of the asymptotes. Write with me. Determine the equations of the asymptotes. Easy 2 marks. Easy, it's a giveaway. Let's say 2 marks. Determine the equations of the asymptotes. Make sure, guys, that you get this easy marks. Don't lose easy marks. Determine the equation of the asymptotes. Remember, hyperbola function has got 2 asymptotes. You can recall, like it has got the vertical asymptote. It has got what? The vertical asymptote. And it also has got what? Horizontal asymptote. Let me try to improve my handwriting. It's not going to be an easy thing to do. Yes, you're welcome. We said the hyperbola has got 2 asymptotes, the vertical asymptotes and the horizontal asymptotes. And we said the vertical asymptote, it is actually the x asymptote. And the horizontal asymptote is the y asymptote. So you must be able to find those 2 asymptotes, the equation of the asymptotes. Can I pick? Is it good if I pick someone? Okay. Or at least. Yes, Arik, give me the equation of the asymptotes. The equation of the asymptotes. Yes, my dear. X equals to 1 and then y equals to -2, correct. Don't make sure that you get these equations right. Agree? So the x asymptote, you equate the denominator to what? To 0, correct. So you say x minus 1 equals to 0, therefore x equals to 1. This is the x asymptote. And what is the y asymptote? Y equals to -2. We are going to bless you with 2 marks. If you write these equations of the asymptotes, we give you 2 marks. The x asymptote and the y asymptote. Now, you must also recall how to present these asymptotes on the graph. Again, you must also know how to present these asymptotes on the Cartesian plane. Let me just draw a small Cartesian plane and remind you how these asymptotes will appear on the Cartesian plane. One, 2. This is the x asymptote, has to pass at 1. The y asymptote is how much? -2. It has to pass at what? -2. So this point is what? 1 and -2. Okay, that point is what? 1 and -2. Now, I go for position latte. Position latte la area. Determine the domain and the range. This one I expect you to get it, all of you, because we talked about it yesterday. Again, the domain and what? And the range. As long as we have got the asymptotes, we can be able to find the domain and we can find what? The range. So what is the domain? The domain, we say x can be any real number, but x should not be the value of the x asymptote. What is the value of the x asymptote? 1, correct. That is your domain. And what is the range? Y can be any real number, but y should not be -2. That is the y asymptote. Okay, no problem.
Guys,
Okay, guys, let's continue now. We found the domain and we also found what? The range. Now, I'm going to ask you the interesting question. Determine axis of symmetry. Determine what? Axis of symmetry where m is less than 0. Don't make noise. Determine the axis of symmetry where m is what? Is less than 0. This is where I want you guys to pay attention. Determine the axis of symmetry where m is less than 0. You can write wherever you are writing your notes. Remember that the axis of symmetry has got, hyperbola has got 2 axes of symmetry. One with a positive gradient. The other one with what? A negative gradient. Please don't forget this. Hyperbola has got 2 axes of symmetry, so one must have a positive gradient. Positive, we just say m is greater than 0. All values that are greater than 0 are positive. And then we say the other axis of symmetry must have what? A negative gradient where m is less than 0. Axis of symmetry has got, hyperbola has got these 2 axes of symmetry. And don't forget that axis of symmetry is a straight line. Again, this axis of symmetry, in this context, we are talking about what? A straight line which pass at the intersection of the asymptotes. The axis of symmetry is a straight line that pass through the intersection of what? Of the asymptote. More vertical asymptote, le horizontal asymptote. Let me just call this point A. At the intersection of the asymptotes, it's where the axis of symmetry will do what? Will pass through. And don't forget there are 2 axes of symmetry. One will be coming in this direction. Let me say it has got a positive gradient. And the other one will be coming in this direction. It has got what? A negative gradient. Here you say m is greater than 0. M is less than what? 0. So the axis of, hyperbola has got these 2 axes of symmetry. Now, pay attention. The one with a positive gradient, it's also called an increasing function. The one with a positive gradient, it is also called what? An increasing function. I'll just write f. The one with a negative gradient, it's also called what? A decreasing function. Okay, let us not rush. Let me ask you this question. Why the one with a positive gradient, it is called an increasing function? Why the axis of symmetry, which has got a positive gradient, it's called increasing function? So we are saying the axis of symmetry, which has a positive gradient, it's an increasing function. Why? If you can study this line, actually, normally we study the graph from the left. So I will touch on the left. What is happening to this straight line? It's going up. So we say this straight line is an increasing function. It's easy to spot whether the function is increasing or decreasing. Just look at it, observe the function from the left. And then where does it go? It goes up. So this function is increasing function. Let us look at this one. You touch it from the left. Observe it from the left. Where does the line go? Down. So this is a decreasing function. The axis of symmetry has got, the hyperbola has got two axes of symmetry. One with a positive gradient, we call it increasing function. The other one with a negative gradient, we call it what? A decreasing function. And uskaba levala or axis of symmetry arena. Keep the straight line. Again? So now here the question says, determine the axis of what? Of symmetry. Actually, we are looking for the equation of the axis of symmetry. We are looking for the equation of a straight line. Axis of symmetry is a straight line. So RED. We are going to first write the standard form of the straight line. What is the standard form of a straight line? Y equals to mx plus c. Yeah, I know. Some in this case, they will do this. They will say y equals to negative x. Maybe they will say plus k plus p plus c plus q, whatever they do. But now I want us to start here. I want us to let us say y equals to mx plus c. Why do I prefer this one? Because this axis of symmetry is a straight line. I want you guys to know the standard form of a straight line. Don't forget the equation of a straight line. We always use this formula, y equals to mx plus c. Again, you are looking for the equation of a straight line. So what do? You say y equals to mx plus c. Remember, the axis of symmetry is a straight line. Now, you are going to substitute the gradient. When you are looking for the axis of symmetry, where the gradient is less than 0, it means that this gradient is negative 1 in this case. So that is why you will have y equals to, if you substitute m with negative 1, you are going to have negative 1 times x. Y equals to negative x plus c. I know maybe I took a long drive to arrive where you guys want me. I'm starting here just to emphasize that we are talking about a straight line. And the gradient in this case is what? Negative 1. The axis of symmetry here, where the gradient is less than 0, the gradient will always be negative 1. It will never be negative 2, negative 3, negative. In axis of symmetry, our gradient is negative 1. So now we just have to find the value of c. We just have to find what? C. Then we know the equation of the axis of symmetry. Mathematically, we have a right. This is the important part now. We have a right to substitute x and y by any point which lies on the function we are talking about. Which function are we talking about? We are talking about this decreasing function. We are talking about the function of what? Of the axis of symmetry. So it's a decreasing function. So we can substitute x and y by any point which is lying on the graph. Do you see a point on the graph? This axis of symmetry, axis of symmetry, when a point here we want to graph now. Which point is that? 1 and negative 2. So I have a right to substitute x and y with what? 1 and negative 2. So it means my x is going to be 1, my y is going to be what? Negative 2. Why do I want to substitute x and y? I want to know the value of c. So what is going to be the value of c? Let's do that. Our y is negative 2. Our x is how much? 1. Plus c. Therefore, you make c the subject of the formula. What is the value of c? Negative 1. So our equation is y equals to negative x, negative 1. This is the equation of the axis of symmetry. Please don't fail this one. If they ask you to find the axis of symmetry, you must make sure that you get it right. Don't fail something you have done in the class. Maybe you can get something new, in the exam, there might be things that are new that can be complicated. But don't fail something which you have done in the class, something which we are talking about. Make sure that you get those ones right. Even if maybe you are not understanding, go and ask, because these things, they might come anytime is tea time. Okay? What about the axis of symmetry? Where m is greater than 0. Arnya get the axis of symmetry where m is greater than 0. The formula, we still do the same thing. Y equals to mx plus c. This is a straight line. But with the axis of symmetry where the gradient is positive, m is going to be 1. So we're going to have what? Y equals to x plus c. You do the same thing. You want to find c? Substitute any point from the graph. Which point is from the graph? 1 and negative 2. So what is your y? Negative 2. What is your x? 1. What is the value of c? Negative 3. Therefore, y equals to x minus 3. This is the axis of symmetry which has got what? A positive gradient, which is an increasing function. Do you see those two axes of symmetry? One king, y equals to what? Y equals to what? You guys seem confused. What's happening today? Huh? Y equals to what? You don't want to talk. Don't worry. Your voice won't appear on the audio. Even if you talk, your voice won't be there. Maybe you are saying, I don't want my voice to be heard. Don't worry. So, what is the... We have got two axes of symmetry. The other one is negative gradient. The other one is positive gradient. Which one do we have? We have got two again. Y equals to x minus 3 is the axis of symmetry with what? With a positive gradient. The other one is what? Y equals to minus x minus 1 is the axis of symmetry with a negative gradient. So we have got two axes of what? Of symmetry. Again. Now in challenge. We said we have got two axes of symmetry. One has got the positive gradient, the other one has got what? A negative gradient. But examiners are very smart. They might say to you, determine the axis of symmetry, which has got the positive y-intercept. Again, the axis of symmetry, level this information on the board. Just ignore this one for a bit. Renale axis of symmetry page. Okano ru calculate the axis of symmetry. Young way about y equals to x minus x plus 5. Young way about y equals to x minus 6. Honyaka the axis of symmetry. Okumana chiche page. Examine now compare the axis of symmetry, which has got the y, which has got the positive y-intercept. Which one are you going to pick? Which one has got the positive y-intercept? The one on top. Again, it has got the positive y-intercept plus 5. This y-intercept is positive. Minus 6. This y-intercept is what? It's negative. Skaba put all the time, but the gradient. They can say to you, determine the equation of the axis of symmetry, which has got the positive y-intercept. Or I was wondering, I get it too. Thing, only the positive what? Y-intercept. So we found the axis of symmetry. What else can we look for? I'm giving you the simplest question now, which is determine x-intercept. Or let me say determine the intercepts of f of x. Determine the intercepts. So what are they looking for? They are looking for what? What are they looking for? If they say determine the intercepts, please do it. This one, I don't expect you to fail this one. Please find the intercepts. Okay? So we know that to find x-intercept, we let y to be what? 0. Mokimor pasango nugget. Apegiri marakacha maalaki. Kenimber butisha renyake x-intercept. You just let y be 0, you collect the marks. Y 0. And don't make a mistake when you are solving here for x. Again, just get what do you do? What do you do when you solve for x here? You take negative 2 to the, you transpose to the other side. Again, it becomes what? 2 equals to 4 over x minus 1. Then what do? Cross multiplication. Again, you say 2 times x minus 1. Which you multiply it. You must apply distributive law. So it's going to be 2 times x, 2x. 2 times negative 1 equals 2. Then what do? 2x equals to what? 6. You take negative 2 to the other side. Again. Then what you do? Therefore, x is how much? This is your x-intercept. What is your y-intercept? y-intercept, what do you do? Let x be what? 0. Y-intercept, let x be 0. So you are going to say f of 0 again equals to 4 over 0 minus 1 minus 2. F into 0 minus 6. So your y-intercept is minus 6. Now you are ready to sketch a graph. Once you have the intercept, you can be able to do what? To sketch a graph. Let us sketch a graph. When you are sketching a graph, please show the asymptotes first. You still remember the x-asymptote and the y-asymptote? X-asymptote, it was 1. The y-asymptote, negative 2. So you say 1, you put a dotted vertical line passing at 1 is the x-asymptote. The x-asymptote must always cut the x-axis. It's a vertical line. The y-asymptote is how much? Negative 2. It must cut the y-axis. It's a horizontal dotted line. So you have shown the asymptotes. What is our intercept? The x-intercept is how much? It's 3. So on the x-axis, you put a point there for the x-intercept. And what is the y-intercept? Negative 6. Minus 3, minus 4, minus 5, minus 6. You put a point there. Now, level A. This point cannot be connected. The graph cannot move from here to here because the graph will never touch our asymptote. So from here, let us approach the y-asymptote. You just do this. From here, we approach the x-asymptote. Sorry for my ugly graph there. Then from here, you go to the y. From here, you go to the x. Let us name the graph f of x. Why won't I get? So you have sketched what? The graph. Okay. Now, after sketching the graph, it's going to be interesting. From here, I will ask you questions that are very, very, very interesting. Okay, so sketch the graph aside there. Just sketch that